Hello again, Paul Watts here, High Flying Physics, helping students get the higher grades at A-level physics. Okay, have a look at this question. The examiner here is challenging many students' common misconceptions that acceleration or deceleration of objects due to gravity is connected to the mass of the object. Let's have a look at it. A solid steel ball x of mass 2m is projected vertically upwards with a speed u. A second steel ball y of mass m is projected at 30 degrees to the horizontal with a speed 2u at the same time. Ignoring the effects of air resistance, which one of the following statements is correct? A. The horizontal component of y's velocity is u. The maximum height reached by y is half that reached by x. X reaches the ground first. And D. X and y reach the ground at the same time. You might want to pause the video at this point and have a go at yourself. It's always a good idea when starting these sorts of questions to draw a diagram of the situation. So there's our x, initial velocity, vertical velocity u, mass 2m. There's our y of mass m, and it's being launched at 30 degrees to the horizontal with an initial velocity of 2u. So let's first of all go through each of the options one by one. A. The horizontal component of y's velocity is u. Should be fairly straightforward. So, as always, we draw a rectangle around our vector. We're interested in the horizontal, as you can see there. So that the horizontal line of the rectangle is our horizontal component. In order to work that out, because the horizontal component is adjacent to the angle of 30, we use cosine. So we can say horizontal component is equal to 2u cos 30, and cos 30 is 0.866, and that comes out to be 1.73u. So that's a fairly simple one to immediately discount, in that the horizontal component of y's velocity is not u, it's 1.73u. So that statement is incorrect. Let's have a look at statement B then. So what we're saying here is that the maximum height reached by y is half that reached by x. So again, the first thing we need to do here is to work out the vertical component of our initial velocity. We take the vertical side of our rectangle, which is effectively opposite the angle of 30 degrees, and because it's opposite, we use sine. So vertical component is equal to 2u sine 30. Sine 30 is 0.5, and that comes out to be u. Now, so what we've got here is we have a situation where both x and y have got the same initial vertical velocity. They've both got a vertical initial velocity of u. Now, acceleration due to gravity does not depend on the mass of objects. You remember the hammer and the feather experiment that was done on the surface of the moon?
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Well, this is illustrating the same point. When an object is launched vertically, kinetic energy lost of the object is equal to the potential energy gained of the object. Kinetic energy lost is a half mv squared. Potential energy gained is mgh. Notice the m's cancel, so mass does not have any impact on the height gained by the object. So we can say height is equal to v squared over 2g. Mass does not have an impact on the height gained. So x and y have the same initial vertical velocity, so they are both going to reach the same height. So again, this statement B, is incorrect. Before we move on to statements C and D, let's just recap the situation. So we know X and Y, they've got the same initial vertical velocity of u. X has got a mass 2m, Y has got a mass m. So we've already established from the previous question that mass does not have an impact on acceleration due to gravity. So the balls with the same initial vertical velocity will reach the same height at the same time, regardless of the mass. And we can say balls will reach the ground at the same time, regardless of mass. All objects will fall at the same acceleration, for the same argument that we said last time. So option C is X reaches the ground first. Well, that statement is clearly incorrect. Option D, X and Y reach the ground at the same time. And that, as we've already established, is the correct statement. Okay, I hope you found that question useful. So remember, mass does not affect the rate at which objects rise or fall due to gravity. Okay, if you found this question useful and you would like a few more, there are loads more on the YouTube channel and on the Facebook page. Make sure you subscribe to these, and look forward to seeing you soon. Thanks. Bye.